Welcome back to Broken to Built. Today we are managing a catastrophic failure of a massive industrial drive gear. The main shaft is completely sheared at the shoulder, which is the point of highest stress. Replacing a component of this magnitude can take months in lead time and cost tens of thousands in lost production. Our objective is to perform a precision structural reconstruction to return this gear to active service. We begin by mounting the sheared shaft on the lathe to true the faces. Before we can join the parts, we must machine away the jagged, work-hardened material from the brake. Using a heavy-duty steady rest for stabilization, we face the end to a perfectly flat, perpendicular surface. This ensures that the two halves will sit flush, which is critical for maintaining a perfectly straight axis of rotation during final assembly. To provide a mechanical interlock beyond just a surface weld, we are boring a deep internal cavity into the shaft. We are creating a seat for a high-tensile internal pilot, or spine. This internal component will act as a guide to ensure both halves are perfectly concentric. We are working within a tolerance of mere microns here. If the bore is off-center even slightly, the entire gear will vibrate and eventually destroy the machine's bearings. Now we shift our focus to the gear side of the brake. We mount the heavy gear in the four-jaw chuck and begin boring the internal diameter to match our new pilot shaft. This is slow, deliberate work because we are aiming for a precision press fit. A press fit ensures that the two components act as a single unit even before the first bead of weld is laid down. We finish by machining a deep V-groove chamfer around the brake, which will allow for maximum weld penetration. Now it's time to join the components. The pilot shaft is inserted into the gear hub. You'll notice the amount of force required to seat the parts. This confirmed that our machining was accurate and the fit is secure. Once seated, we verify the total length and check the runout. Any wobble at this stage would mean we have to start over, but as you can see, the alignment is dead on. The welding process is the most critical stage for structural integrity. We are using a multi-pass welding technique to fill the V-groove. We aren't just joining the surfaces, we are fusing the metal deep into the core of the shaft. We carefully manage the heat input to avoid thermal warping, which could pull the shaft out of alignment. This metallurgical bond will allow the shaft to handle the same extreme torque loads it was originally designed for. After the weld is cooled, we return the entire assembly to the lathe. We machine away the excess weld material to restore the shaft to its original diameter and specifications. We then use a precision grinder to smooth the surface, removing any stress risers that could lead to future cracking. The result is a seamless transition that is virtually indistinguishable from a factory new part. Now the repair is complete. We've taken a piece of industrial scrap and transformed it back into a high-performance drive component. By opting for a precision rebuild over a replacement, we've saved the client significant downtime and expense. This is the standard we set at Broken to Built. If you value precision engineering and industrial restoration, subscribe for more.